Hello everybody, this is going to be the tutorial video for section 13.3 day 2. So we're continuing to look at measuring radians on the unit circle, and we're going to kind of take it into quadrants 2, 3, and 4 today using radians and finding sine and cosine. Very similar to degrees, there's one extra step, not too bad. So let's start with a warm-up. This was what we were looking at yesterday. We want to convert radians to degrees in the first two. So as a reminder, let me make sure my pen works here. Whenever we're converting radians to degrees, oh, there's the daily lag. Hang on a second. Radians, 2 degrees, reminder, you multiply by 180 over pi, because that's what makes those pi's disappear. You have one on top, one on the bottom, they're going to cancel out. So in the first one, if I want to convert 3 pi over 2 back to degrees, I'm going to multiply by 180 over pi. This pi on top, this pi on the bottom cancel each other out. Pi divided by pi is 1. And then I multiply what's left. 3 times 180, you can do that on your calculator. That would be 540. And then I have a 2 on the bottom. Type that in. 540 divided by 2 would be 270. So this would be 270 degrees. Second one, same thing. I'm going to multiply by 180 divided by pi. Just like in the last one, pi on top, pi on bottom. They're gone. Where did they go? I don't know. 180 times 11 up top, 1980. Divided by 9. It's the only thing left on the bottom. Hit divided by 9, 220 degrees. No need to round anything because they come out to nice clean whole numbers. If we're going to do it in reverse, instead of multiplying by 180 over pi, if I want to go from degrees to radians, I need that pi to appear, not disappear. So I'm going to multiply by pi over 180. This time the pi's on top. So in the first one, I have 210 degrees. I want to convert that to radians. I'm going to multiply by pi over 180. So we saw this yesterday. The 210 and the pi are both in the numerator, so you can put those together. You have 180 on the bottom. You need to reduce this portion, 210 over 180, because we want to leave our answer in terms of pi. So you know that there's going to be a pi involved in your answer. Now you just got to figure out what fraction goes in front. Type in 210 divided by 180. You get a long decimal. No, don't worry. Hit math. Hit enter twice. 7 over 6. So we would write that as 7 pi over 6 would be the radian measure. Same thing with 160 degrees. I want to go 2 radians, so I need pi to be up top. I need 180 to be on the bottom. You can put the 160 and the pi together, but you got to make sure that you simplify the 160 over 180. So type that into your calculator and then hit math, enter, enter. 8 over 9. So this would be, oh, I need a pen, not a highlighter. 8 pi over 9. Okay, so just a little recap. We're going to need that for what we do now, which is find the sine and cosine value on the unit circle. So if you remember, anytime we're on the unit circle, do my best version of a circle. The radius of that circle is 1. And any point on that unit circle, any xy ordered pair, is represented by cosine of this reference angle, which touches the x-axis, and the y value is the sine of that reference angle. So x goes with cosine, and y goes with sine. And if we've done this in degrees before, and we started doing it in radians yesterday on the axes and in the first quadrant, really all you got to do, if you don't like doing the problem in radians, the first thing you should do is convert it to degrees. So you would multiply by 180. Let me make that a little bit more legible. Multiply your radian measure by 180 over pi. So now you've got your angle in degrees instead of radians. And the rest of the process is a matter of drawing your triangle and using your 30, 60, 90 rules or your 45, 45, 90 rules to figure out the sine and cosine value. So let's take a look. First one, I have pi over 4. First thing I'm going to do, I'm going to figure out what the degree measure would be for that. So I'm going to multiply by 180 over pi. Pi's cancel out. 180 divided by 4, if you type that in, would be 45 degrees. So now I think about this problem completely in degrees. This is a 45-degree angle, which is in the first quadrant. Here's 0, here's 90, here's 180, here's 270, and now I'm back to 360, full circle. You could sketch the angle in standard position formally if you want. You don't have to, but you should draw your triangle. Here's my 45-degree angle. There's the reference angle, 45. Here's my triangle, 45, 45, 90. The radius of the circle is 1, so that's the hypotenuse. And we've seen this trick before. If you're going to go backwards to the legs, it's L, L, and this is your L rad 2. So if you go backwards, 1 divided by rad 2 would be rad 2 over 2. And since I'm in the first quadrant, everything in quadrant 1 is positive. So cosine should be positive and sine should be positive. Okay. So sine is y, cosine's x, but they both happen to be rad 2 over 2 in this case. Okay. Second one, 2 pi over 3. First thing I'm going to do, I don't want to deal with the radians. I want to deal with degrees. So I'm going to divide by or multiply by 180 over pi. Pi's cancel out. I get 360, 180 times 2. Yeah. 360 divided by 3 would be 120. So think about on the unit circle, here's 0 degrees, here's 90, here's 180, here's 270, here's 360. 120 is going to be in that second quadrant between 90 and 180. So here's my initial side, here's my terminal side, there's 120. That reference angle from 180 backwards to 120, you backed up 60 degrees. So you have a 60-degree reference angle. Here's your triangle, 60 in the bottom corner, 30 at the top. The radius is 1. And then we've seen these tricks before. The side across from 30 is L. Your hypotenuse is 2L. And the 60 side is L rad 3. So if I go backwards from 2L to L, if 2L is 1, L is going to be a half, but it's going to be negative since you're going to the left. And then if you tag a rad 3 next to that, you're going to get positive rad 3 over 2 since it's going up. Where am I getting my negatives and positives? Because I'm in quadrant 2, any ordered pair there is going to have a negative x value and it's going to have a positive y value. So cosine should be negative, sine should be positive. So my ordered pair there is negative 1/2 comma rad 3 over 2. So the sine of 2 pi over 3 would be rad 3 over 2. The cosine would be negative 1/2. Cosine is x, sine is y. Next one I'm going to do is negative pi times 180 over pi. This one's nice because the pi's cancel out. So I have a negative sign left over and 180. So I'm at negative 180. We can still do old tricks. If you don't like dealing with negative angles, you can add 360 degrees to make it positive. 360 minus 180 would give you positive 180, which is going to be right over here. Here's 180. There's really no triangle to draw for this one since it's a quadrantal angle. It lies on one of the axes. So you just got to remember the radius of that circle is 1. So that ordered pair would be negative 1, 0 since it goes to the left. Here's my ordered pair. Cosine is x, sine is y. So the sine would be 0. The cosine would be negative 1. So I'd say like 90% of this process is the same thing we were doing in section 13.2. The only difference is I'm converting the radians to degrees first since they gave me the problem in radians. If you're getting the hang of some of these and you don't need me to keep explaining, you can kind of pause, try some out, and you can check my answers. If you'd rather watch me go through a few more, feel free to keep watching. But I do want you to complete these. Okay? Whether you're watching every single minute or checking it over, you can skip through the video if you need to. 11 pi over 6, I'm going to multiply by 180 over pi to convert to degrees. 180 times 11 is the numerator, 1980. And I'm going to divide by 6. So this is 330 degrees. Here's 0, 90, 180, 270. Full circle brings me back to 360. So I'm going to be 30 degrees away in the fourth quadrant. If I go all the way around, this would be 330. My reference angle here is 30 degrees. So if I draw my triangle, there's my hypotenuse, which has 1 unit in length. There's my right angle. And there's my 30-degree reference angle. So the one at the bottom would be 60. Here's 2L. Here's L across from 30, and here's L rad 3. If 2L is 1, L is going to be a half, but since it's going down, it's going to be negative. L rad 3 is going to be positive since it's going to the right. It's going to be 1/2 rad 3, otherwise called rad 3 over 2. Again, where am I getting my positives and negatives? Fourth quadrant, x is positive, y is negative down there. So cosine is positive and sine is negative. My ordered pair would look like this. Positive rad 3 over 2 to the right, down 1/2. So sine would be negative 1/2. Cosine would be rad 3 over 2 at 11 pi over 6. Next one. This one looks a little bit easier. Just pi over 6. So times 180 over pi. Pi on top, pi on bottom. Say goodbye. 180 divided by 6 would be a nice 30-degree angle. So it lands us right in quadrant 1. This is 30. So that's your reference angle. Because this is 0. So it's 30 degrees away from 0. Draw your triangle. This is 1 unit in length, since that's the radius of the circle coming out of the origin. Moves to the right, moves up. So I know it's going to be positive, positive, since it's in quadrant 1. The 30 degrees always touches the x-axis. Your reference angle touches the x-axis. In this case, it's 30. There's my 60 at the top. There's my 90 in the bottom right corner. Here's L across from 30. 2L is your hypotenuse. L rad 3 is across from 60. So L would be 1/2, and L rad 3 would be rad 3 over 2 in this case. Okay. Cosine is x, so this one's your cosine. Sine is y, so this would be your sine is 1/2. Both positive because I'm in quadrant 1. 5 pi over 6. Same trick, times 180 over pi. Pi's cancel out. You can put this in your calculator, 180 times 5. And then I'm going to divide that 900 by 6. So now I have it in degrees, 150. I would put your quadrantal angles so that you have a reference point to look at. There's all the ones we're used to. 150 is going to lie between 90 and 180. Here's the initial side of the angle. Here's the terminal side. From 150 to 180, you got 30 degrees left over to that negative x-axis. So here's your radius of 1. There's the hypotenuse. And then here's my triangle. It's going left and up. So I know in quadrant 2, cosine is going to be negative. Sine is going to be positive. Here's 30 in the bottom right, 60 at the top. Across from 30 is L. My 1 is 2L. So L in this case would be 1/2. And L rad 3 would be negative rad 3 over 2, since it's moving left. So cosine, negative rad 3 over 2. That's my x-coordinate. And sine would be positive 1/2. That's my y-coordinate. Okay, if you need to pause anything or go back and take a look at some of these, go for it. We got 2 left. Again, if you're getting the hang of this and you want to try these out yourself first, go for it. If you want to see a couple more modeled before you start the Math Excel, I'm going to keep going with these last two. 3 pi over 2, I'm going to multiply by 180 over pi. 180 times 3 would be 540. 540 divided by 2 would be 270. And that's right at the bottom of our circle. 0, 90, 180, 270. This one's a quadrantal angle since it's on the y-axis. No need for a triangle when it lies on the axes. You just got to remember your zeros and ones. This ordered pair doesn't move left or right at all. So the x value is 0. But it's going down, and down means negative. If this is the center of the circle, not a very well-drawn circle, sorry. This is 1 unit long from here to here, but it's going to be negative since it's going down. So there's your cosine, there's your sine. Cosine would be 0, sine would be -1. Okay, last one. -5 pi over 4. I can already tell I'm probably going to do some type of coterminal angle, but I'd rather do it in degrees instead of radians. So I'm going to switch it to degrees first, and then I'll add 360. So I'm going to multiply by 180 over pi. 180 times 5. Technically -5. There's a negative in front, so let's include it. -900, and then divided by 4. That's all that's left in the bottom. -225. So at least it's in degrees, but it's negative. I would rather deal with counterclockwise positive motion since that's what we're used to. So I'm going to add that coterminal 360 to give me that coterminal angle. You should already have -225 on your screen. All you have to do is hit +360. It'll take your answer and bring it down. 135 looks a lot easier to deal with than -225. And remember, the standard position sketch would be a little different because 135 you're going to sketch counterclockwise, whereas -225 you'd sketch clockwise. But the initial and terminal side are going to look the exact same on the sketch. That's why that works out. The sine and cosine value aren't going to change. So it's going to land in quadrant 2 no matter what. So here's 130. Here's 0, 90, 180, 270, 360. Here's my 135. And if you subtract 180 minus 135, you can get the reference angle. There's a 45-degree angle between the negative x-axis and that 135. There's my hypotenuse of 1. There's the radius of the circle. There's my triangle. 45 reference. You also need a 45 at the top in order to add up to 180 degrees in the triangle. Okay, quadrant 2. Negative x-coordinate, positive y-coordinate. So cosine is going to be negative, sine is going to be positive. You've got equal legs, LL, and the hypotenuse is L rad 2. So to go backwards, you got to divide by rad 2. That's going to make this negative rad 2 over 2. It's going to make the y-coordinate positive rad 2 over 2. So cosine is this one, and sine is this one. X, Y. Sine is going to be positive rad 2 over 2. Cosine is going to be negative rad 2 over 2. And that's it. Really, the additional step here is converting from radians to degrees first so that it's easier for you to deal with. The rest of it is just drawing your triangles and continuing to practice your 30, 60, 90 and your 45, 45, 90 rules. All right, if you're done with those, you can go back and watch certain parts of the video if you need to. If you're ready to go, you can get started on your homework. Have a great rest of your day. Happy trigging.